Hello, welcome to all. Today we design and simulate a three-phase transformer by using UDP. UDP is user-defined primitives. In user-defined primitives, we have already have a design in your RM export. You put the values of core length and core height, and it automatically design the core. We'll start. In this we overall design the design of core in this experiment. Coil and region identical to one used of previous 3D designs, and we here we use use UDPs. It's save the time. Okay, to start, first go to your ansys electronics, double click and wait. Okay, this is your ansys electronic desktop. Explore Maxwell's, click on Maxwell 3D. This is your modular window. X plane, Y plane and Z plane. So start with first step. First step is set solution type. Go to Maxwell 3D, click on solution type. Solution type is transient. Click on OK. After the completion of this step, insert the transformer core from UDP. For this step, go to draw and search use and define primitives. Select RM export and click on transcore. This is your transcore, and click on OK. Okay, this is your transformer core. Okay, go to go to history tree, double click on transcore, change the name is core, and next step is assign material, edit, and click so all libraries and write down M15 underscore 29G, select. Okay, and next step is sign color. Okay, after that next step is insert transcoil from UDP. Okay, again go to draw and search user defined primitives, RM export, click on transcoil. Okay, this is your transcoil, and press OK. This is your transcoil. After that next step is go to history tree and double click on transcoil and change the name is coil, and assign material. Next step, assign material is copper. Assign copper material, change the color, click on OK. This is your coil. After that next step is change property layer to 1. Okay, so in coil we have some changes. Go to history tree and double click explore coil and double click on create user defined parts. Here search layer, change layer 10 to 1 and click on OK, and rotate this transformer Okay, it's clearly visible. Okay, so next step is copy trans coil from UDP. Go to edit, first select coil and click on edit and select copy and click on copy, and again go to edit and click on paste. Okay, next step is change properly within to 64. This is your copied coil. So go to your history tree and double click on coil 1, explore coil 1 and double click on coil 1, create user defined parts. Here change width in to 64 and depth in is 64 and radius in is 32 mm and click on OK. Okay, so this is your lower voltage winding. Okay, this is your lower voltage winding and this one is your higher voltage winding, and this is your transformer core. Okay, after the completion of this step, after the completion of this step, select coil and coil 1 from your history tree. Select coil and coil 1 from your history tree and go to modular, search boolean and click on separate bodies. Basically here we create 6 winding object. Okay, click on separate bodies. Okay, change the color. We are manually change the color one by one. Okay, next step is cut the model along XY axis. For this operation, go to edit and select all, and next step is again go to edit and go to modular, search boolean and click on split. Here select split in XY XZ direction, and press OK. And rotate the transformer. here we cut the transformer in x z axis. Next step is set symmetry multiplier. Okay, go to Maxwell 2D and search design setting and search symmetry multiplier. This is your symmetry multiplier. Right, change the value is 2 and press OK. After the completion of this step, next step is define region. For define region, go to draw and click on define region. Here percentage offset value is first padding data is pad all directions similarly, and padding type is percentage offset, value is 20. Press OK and double click on create simulation region to modify the setting. Here double click on your create simulation region. Go to your history tree and this is your region. Double click on create regions and change the value of -y. Change the value of -y padding data to 0. Right now it's 20. Change the value is 0 and press OK. Okay, next step is assign excitation. Okay, rotate model in x z view. This is your x z view and press the F key from your keyboard and select the faces. Select 6 internal coil cross sections. Select here one by one. This is your lower voltage winding. Select all internal windings. Select all lower winding 1, 2, 3, 4, 5 with the help of control key and right click on any coil and assign excitation to coil terminal. Here number of conductor is 100 and press OK. After that, the next step is select higher voltage winding. First select F from select F, press F and select all higher voltage winding and again right click on any coil, assign excitation to the coil terminal. This is your higher voltage winding, conductor is 400, press OK and change the direction. Okay and next step is change the directions of excitations. Okay, select coil terminal 2. Okay, this is your go to project manager and first check all even number. ठीक है, all even number is this is your even number coil, means this is your even number here. Even number is 2, 4, 6, 8, 10 and 12. All select point out of terminal. Okay, all these are selected point out of terminal. Point out of terminal. Okay, all even coils. Okay, double click. Okay, go to view, click on properties and select for coil terminal 2 point out of terminal, for 4 point out of terminal, for 6 point out of terminal, for 8 select point out of terminal, for 10 select point out of terminal, for 12 select point out of terminal. Check one by one. Again, odd numbers are means right hand side, this is your right hand side, and left hand side. Right hand sides are out of terminal, and left hand side point terminal. Okay, so all check out of terminal. This is your right, this is your right. Out of terminal, out of terminal. Okay, check one by one. 6 is out of terminal, 8 is also out of terminal, 10 out of terminal, 12 is out of terminal. Okay, it's correct. And after the completion of this step, assign create winding. For create winding, we have already know how to create a winding. Go to project manager, right click on excitation, click on add winding, and name is primary A. Name is primary A. Voltage, click standard, check standard, and initial current, don't put the value. Resistance is 2 ohm, don't write down inductance value. Voltage is 54. Use a multiplication symbol and write down sign, and use small bracket, write down 2, put the multiplication symbol, write down pi, put multiplication symbol, write down 50, put multiplication symbol, write down time and close the bracket. Change the unit is a volt. Okay, check the value. Okay, it's volt, make it okay. And repeat the same step, create 2 more windings. This is your primary B, voltage trended, voltage value is same. Change phase degree is 120 degree and all values are same. Change the unit, is volt. Click on okay, resistance is 2 ohm. Click on OK. Again repeat the same step, add winding is primary underscore C and type is voltage trended, resistance is 2 ohm. Change the phase degree, plus 240 degree and select unit is volt. Click on OK. Okay, next step is create secondary winding. This is a full load analysis. Here resistance for full load analysis, we have a resistance value to 100 ohm. Here we create a secondary ABC winding. Right click on excitation, add to winding. Winding is secondary underscore A and type voltage is trended, resistance is 100 ohm, resistance is 100 ohm and don't change the other values. Click on OK and again do the same step, secondary B, voltage trended, make it OK. Change the resistances 100 ohm, make it OK. Again right click on excitation, add to winding is secondary C, voltage, type is voltage trended and resistance is again 100 ohm and click on OK. This is your 6th winding. Next step is we have already know what is the next step. Next step is add coil into the windings. Right click on coil and paste in manually. This is your primary winding, primary C. Add to winding. This is A, this B and C. So this is your primary C and this is your primary C. Again right click, add to winding, primary C. This is your primary A, add to winding, primary A. This is also primary A, add to winding, primary A. This is your secondary primary B. Add 2 winding, primary B, and this is your again primary B. Add 2 winding, primary B, and this is your add 2 winding, this is your secondary C. Add 2 winding, secondary C. Add 2 winding, secondary A. Add 2 winding, this is your secondary A. Add 2 winding, this is your secondary B. Add 2 winding, this is your secondary B, and check manually. This is your primary way, this is your primary A, both coils are selected. Primary B, both coils are selected. Primary C, both coils are selected. Secondary A, both coils are selected. Secondary B, both coils are selected, and secondary C, both coils are selected. This is the correct. After that, the next step is set eddy effect. Okay, for set eddy effect, go to project manager, right click on excitations and click on set eddy effect. Here uncheck all and press OK. After that, create analysis setup. For analysis setup, first go to Maxwell 3D and search analysis setup, add solution setup. Here stop time is 40 millisecond and time step is 1 millisecond, and go to save field tab. Here start time is 20 millisecond and stop time is 24 millisecond and step size is 1 millisecond, and click on add to list. This is your time step, and next step is go to solver tab and write down value of non-residuals is 1e minus 4 and press OK, and go to Maxwell 3D, click on validation check. Okay, so the analysis setup, save fields, okay. Go to Maxwell 3D, click on analyze all, save the project. 3D transformer, save and wait. Okay, check the messages. Normal completion on server. So this is a 3D model, it's take more time as compared to 2D. I already told you for detailed analysis we use a 3D analysis. For less information we use a 2D model. Okay, so what is the next step? Next step is create a field plot for a flux density. Here we plot a flux density plot. Okay, place model in XZ direction view, and click F and select all faces. Okay, click press F key from your keyboard and select transformer core, and go to Maxwell 3D and fields, click on B magnitude. Here select in volume core, and time is -1 second. It's already selected, and press done. Okay, go to view, set solution context. Here select time. Suppose I select 0.002 second. This is your flux density plot. After that, go to view and click on animate, click on OK. This is your flux density plot. With respect to time, flux density is changing all limbs and your whole transformer core. Okay, so next step is close this, and next step is plot the currents. For current plot, go to Maxwell 3D, results, create an transient report, rectangular plot, select current primary A, select current primary A and secondary A, primary A and secondary A with the help of control key, and click on new report. This is your current plot. Okay, and next step is right click on plotted area, trace, search after that trace characteristic all, this is a trace characteristic. Click on all and scroll, select maximum, select maximum, and next specifies the range. For a specified range, click on values specified. Range is 20 millisecond to 40 millisecond. After that, click on add trace characteristic. Okay, next step is plot the primary and secondary induced voltage value. Do the same step. Go to Maxwell 3D, results, create transient plot, click on rectangular plot, select OK, results, transient report, rectangular plot. Here select induced voltage primary A, induce voltage primary A, induce voltage secondary A, and click on new report. This is your induced voltage primary A, and this is induced voltage on primary secondary B. So this experiment is completed here. Okay, next is